Alright, so we're going to go ahead and get started here. Make sure you have a pencil out. Last class we worked on freehand 2D sketching. Today we are going to be moving into the next dimension. If not everybody has paper, it was being passed around. Do we know where it got stopped? Alright, I think it's on the end of this table over here. So does everybody back over there have paper? Do you guys have paper? Okay, so I just got stuck there. Cool beans. Alright, so like I said, last time we worked on two-dimensional freehand sketching. You don't have to get it out, but just as a reminder, this is the paper that we worked with last time, or at least very close to it. I don't remember if this was second hour or fourth hour's version of the drawing, but it was similar to this, where we did straight lines, we did some geometric construction, we did a little bit of angling intentionally, and then we did a two-dimensional shape that you might find as an engineering drawing. Today we're going to move on and add the third dimension to what it is that we're drawing. And to do that, we're going to talk about a few different things here. So I'm going to clip here. Essentially, when you are successfully making three-dimensional drawings, you are essentially creating the volumetric envelope. And that's what we're going to be talking about today as a whole. It is three-dimensional drawing on a two-dimensional plane. Because remember, no matter what we do, when we're drawing on a piece of paper, unless we start folding the paper, all that you can do is a two-dimensional plane. It only has width and it only has height. So what we're going to look at today is volumetric accuracy, and then what's called structural integrity. To do that, there are some key terms that we're going to look at. In this case, we're going to talk about form, which is the structural volume or mass of a three-dimensional object. 3D, in this case, which is the representation showing the height, width, and depth of the object. And then we're going to do visualization, which is the mental process of seeing that object in space, in virtual 3D or just in your own headspace. So looking at our definitions, we're going to look at three-dimensional to start with. So if we look at our drawing over here, you see that the first side of it, I guess, is just a two-dimensional XY axis. This is what we worked with last time. What we're doing today is we're adding the depth axis, or the Z axis. That's the one angling right here. This is a three-dimensional plane construct. It's something that you'll be very familiar with once you start doing three-dimensional drafting on the computer. Because even in three-dimensional drafting, most of the time you start off with a 2D plane and you pull it into a 3D shape. But that's something we'll talk about later. The technical definition of the third dimension, or 3D, is a spatial representation encompassing the three fundamental axes of physical space: height, width, and depth. It says the three fundamental axes because you can make as many off-axes as you want. But you always start with these. We have the definition of our axes. So we have the height, which is our y-axis in terms of the drawings that we do. It's the vertical dimension of an object, so from the bottom to the top of the page. Then we have the width axis, or the x-axis, which is from the left to the right, or the right to the left, depending on which direction you're going. In 3D sketching, the combination of the height and the width establishes what the primary scale of the drawing that you're doing is. And then we have Z, or the depth axis. This is the receding dimension of an object extending back into the space away from your plane of vision. Looking at the drawing we have over here on the side, this is one of two ways that we're going to talk about doing three-dimensional drawing today. This specific one is called an isometric drawing. And the way that you can tell that is that there are no horizontal lines normally that can make up the width, the depth, or the width or the depth of our object. Now we're going to talk about a different type of three-dimensional drawing here in a few minutes. That's what we're going to do first. This is different than this. But when we're doing isometrics, and that is the primary type of drawing that you're going to be doing as a part of this class, you're going to take all of your, anything that could be a horizontal axis, but not the height, and you bend it up to 30 degrees. You basically set the whole thing on a point. So we have form and shape. We talked about form a little bit. Structure. The form is the structure or mass or volume of a three-dimensional object. While shape refers to the boundaries, form refers to or implies the occupation of three-dimensional space. And the last bit we talked about is I mentioned that we were going to talk about is 3D visualization. 3D visualization is a mental process. There are some of you who will never be able to do this properly. Here, so let me ask you a question. When you are thinking through something, when you are composing a letter or reading something, inside of your head, do you hear a voice, yours or somebody else's, reading or thinking, or maybe not talking to you, but playing out what you're going to say, or something like that? Or do you just hear silence, or do you see pictures? Seriously. Both? So, the vast majority of people have what's called an internal monologue. It's when you talk inside of your head and think things through, and there are some people that don't and have no concept of that at all. It's the same thing with 3D visualization. Some people can literally think about an object, figure out how it fits together in their head, and then translate that to the real world. In the exact same way, some people have no concept of how that happens. They have to physically draw it out, or they have to piece it together in the real world. This ties back to a theory that you'll hear in psychology about different types of intelligence. And that doesn't mean like stupid people or smart people or some mixture of the two. It means you learn better through a certain type of thing. So one of them is body and kinesthetic. So you learn better by physically doing. One of them is visual spatial, which is learning by seeing and putting together in your head. So there are a whole bunch of different ones, but if you are strong in visual spatial intelligence, then usually you are a lot easier, or you have a lot easier time putting together 3D objects. If you are weaker in that area or can't do it at all, it doesn't mean that you are going to have any problem. It just means you have to think it through a little bit harder in order to do that visualization. One of the ways you can help with that is what's called the glass box method. So it's kind of a small picture. I should have zoomed that in. But what we have here is a three-dimensional shape sitting inside of a transparent cube. Looking through the sides of this cube, you have the different views of a shape. We're going to talk about this quite a bit later when we start doing orthographic projections. But essentially, if you could imprint the lines that you can see on each face of that cube of the shape onto the cube and unfold it, then you have a full set of drawings for that shape. We're going to spend some time doing that. But this can also help you piece together how the shapes fit together in the first place. So what we're going to do is I'm going to demonstrate some three-dimensional sketching techniques. You'll go through and do those with me. And then you'll have an assignment to do a couple more. And it'll all be on this same piece of paper. Alright, so let me flip over to the screen and we'll get started on this. Minimize. There we go. There we go. Okay, so like I said, this is the one we did last time. We're going to start off today by sketching out a representation of our title block. Something that you're going to have on all of your drafting tools, or tooled drafting assignments, pardon me. But essentially, we're going to start, let's see, I'm going to bend this down a little bit more because that's way out of my drawing comfort zone. Okay, so what I want you to do is on all four corners of the paper, you're going to come in just a little ways. You're going to rough estimate about 1/4 of an inch. If you don't do that very well, just a little way from the edge. As long as you're trying to be consistent, you'll be fine. Again, the more you do things in this class, the easier it is to visualize things like what is 1/4 of an inch. Now, it's kind of hard to see on my drawing here, but we do have our four corners here. And what you're going to do is you're going to use the straight line techniques that we talked about last class, and you're going to connect those 4 dots around the edge. We're making the border of our title block. So just small, light, overlapping lines, all heading towards the target dot on the other side of the paper. Just like that. That help any? Change the contrast. There we go. And you're going to do this for all 4 sides. Luckily, you've got the edge of the paper here to help tell you if you're wavering off of your distance here. Also, since we're not doing this with the drafting tools, your paper is not taped down to the table or your drafting board in the case later. So you're free to be able to rotate it around into whatever is the most comfortable way for you to make a straight line. So we have, or you're still working on it, but we have the border of our title block here. You're going to choose one of the long ends, I don't care which, and you're going to come up about the same distance as you did from the edge of the page to the line. And you're going to put another dot on both sides, just like that. So dot here, and you're going to connect that as well. Alright, so you should be left with something that looks like this. Can I change my focus? Let's see here. There we go, that's better. I was out of focus. Alright, anybody need a second or two more for that? Cool. Alright, so we're going to put 4 pieces of information in our little box down here at the bottom. First, on the left side, moving to the right, obviously as you write, we're going to put our first initial and last name in the drafting lettering that we talked about before. About center, you're going to put the lab title, which is 3D Sketch. About a half of the remaining distance over, you're going to put the hour, so P2. And then finally next to it, you're going to put the date, which is 1-21-26, which is so strange to say. All right, so once we have this done, and once you get your drafting templates for when we're actually doing the mechanical drafting, it's going to be subdivided into quadrants for you so that you can easily see where each of your orthographic projections are supposed to go when we're drawing. What we're going to do is basically start off by focusing in this upper quadrant. You don't need to fold the paper, you don't have to get exact here. But we're going to focus on this upper corner here for what we're starting drawing, and I'm going to zoom in a little bit so you can see better. And essentially what we're going to do is we're going to come down. So if where my index finger is about the middle of our paper, we're going to come down about 3/4 of that space. Remember, you are eyeballing this. If it's not exactly the same as mine, you're fine. And I put a little dot just to remind myself of where that is. And then I'm going to come over about the same distance from what I am judging to be the center. And put another dot right there. This is going to be the starting point for the drawing that we're going to do. So if my index finger is the midpoint along the edge, this is about 1/4 of that distance. And this is about the same over. Alright, so from here, we're going to start off with this drawing just like we did last time when we were making a square. You don't have to do the whole scaffolding thing like we did last time. If you are able to just eyeball out a decent square, that's perfectly fine. We're going to try and judge this to be about 1 inch tall and 1 inch wide. And a fun little fact about human biology is that on the index finger, for most individuals, one of the segments between where your finger bends is probably pretty close to 1 inch. So for me, from the index finger to the first bend to the end of my index finger is about 1 inch. And I'm going to use that as a judge to draw my square. Not a straight line, or straight edge obviously, but just so I can get 1 inch square, I'm going to do that. That was a bit long. And there we go. So I got a square, not too bad, a little lopsided, but nothing crazy. You can use an eraser to clean up the corners if you need to. Just like yesterday's quote of the day said on the board, nobody's perfect, that's why they make erasers. So this is one of the 2 types of 3-dimensional drawing we're going to talk about today. This one keeps a true height and a true width to our shape, but kind of messes with your perspective when it comes to the depth. So pay attention, here's what I want you to do. Starting at this corner here, because it's going to be the easiest to see, you're going to draw a line at as close to a 135 degree angles you can get, or 45 degrees off of the corners. So like if we were to extend that out, pretty close to 45 degrees right there. You're going to make this an inch, just like the rest of them. Just like that. It should basically divide this. If I was to connect this point to this point, it would be a line that kept going. And I'm going to draw that exact same line at all three of the other corners of my square, because my square is rapidly becoming a transparent cube. Okay. And then all I'm going to do to finish this is connect those lines. Now, some of you are going to be able to look at this and instantly see that this is supposed to be a cube. Some of you are still going to look at this and see nothing but a tangle of lines. And that's okay. There's kind of an aha moment for some people when it comes to 3D shapes. For example, if you are looking at one of those pictures that looks like a candle or like a candlestick or a vase or something, that's black and white, and then all of a sudden like your brain clicks and you can see two faces looking at each other. That's kind of the same deal when it comes to 3D shape connection. For some people, it just takes that click. Now, this is as though this cube is completely transparent. We can see the back corners that would be covered by the faces that are closer to us. Excuse me. It also allows us to, if you can make the visual switch, right now this cube, as we drew it, this is the face that's closest to us. If I were to shade that in, it would look a lot more like this is the front edge, and that's the back. However, if your brain can make the mental switch, this just as easily could be the closest square to us, with this being the receding edges and this being the back. It's kind of trippy. It's definitely an optical illusion, but in the end, it comes down to other things that you're going to do when you draw 3D shapes to help you determine which one is which, I guess. For example, we did this on purpose so that you could see the structure of the back side of the cube. Ordinarily, when you're drawing in 3 dimensions, you don't see through the object. And we're going to do that with the next one here. So while you're finishing that up, I'm going to start a little bit at the next bit here. I'm going to come about the same distance down and at about the center of the page, and I'm just going to draw a nice little horizon line here. And then I'm going to, in the center, put a dot. Let's get you guys to that point, and then we'll move on after that. So like I said, we aren't going to use this to actually draw our angles, although we could. That's not the point of this particular lesson. What we can do is use this to visualize what a 30-degree angle is, and that's what we've got going on here. If this is 0 going straight, this is 30, or rather negative 30, going back in that direction. If I flip it over, you get the same thing on the other side. What you're going to do, without using the triangle, is draw a 1-inch 30-degree angle going away from our center dot here. That's probably way too much in terms of an angle. And you're going to do it on both sides. The line should be about an inch. And you should end up with, I don't know, Plankton's eyebrows. I don't know, he's angry. I don't know. SpongeBob was my sister's generation. So we have these two going out in this direction. They should be about an inch. And then I'm also going to draw one line straight vertical that's about an inch. Just like that. So what we have here is the beginnings of two faces of our isometric cube. If we looked over here, and I'm going to use my eraser and erase little bits of these lines that would be the back side of the cube. If we had drafting tools, I would have you have your erasing shield out. And one of the functions of that tool is to help create hidden lines by giving you small holes that you can erase through to achieve this same effect. But by putting these in, it helps us solidify that this is the front view, or at least the one that's closest to us. So I'm going to put a front view there. This is going to be a right side view, and this is going to be a top view. Okay? We're going to do that same thing here. So from each of these, we're going to do another line straight up that's about an inch. Oh, let me come out here. Once you have those, you'll connect them at the top. So now we have what kind of looks like an open book shape. I mean, you can kind of see that inside pieces like it's on display. But what we're going to do is essentially mirror this line coming out of this corner. And then we're going to mirror this line coming out of this corner. And if you didn't go down far enough, you're going to go into your title block. Usually we don't want to do that, but I'm not too concerned about it for this assignment. And once you connect those two, sometimes like this is the point, this is that aha moment I was talking about earlier, where all of a sudden it goes from looking like a book or something to like a cube where you're looking on the end of it. When it comes to isometrics, anything that was a horizontal line becomes a 30-degree angle. Anything that was vertical stays vertical. So this would be my front, this would be my right side, and this would be my top. Yeah, I don't know who you are. I'm not opening the door for you. All right. So once you have been able to do that, your assignment is to draw 4 more shapes, but they can't be cubes, in the space on the rest of this paper. So draw 4 more shapes that are not cubes, using either of the 2 types of 3D projections that we've talked about. So either the pictorial drawing or the isometric drawing. You can do cylinders, you can do triangular prisms, you can do rectangular prisms, just no more cubes. You're going to draw 4 more shapes so that you'll have a total of 6 on the paper. Once you've done that, take a picture with your computer and you'll turn it into the assignment on Canvas called 3D Sketch, like Lab 2, I think, is what it's called. Let's see here. All right, any questions before I let you run off to do this? All right, if you do have questions, just let me know. Otherwise, finish this up and you have the rest of class to make sure this is right. That's about 25 minutes.